All right. Well, one other job announcement, by the way, because I just remembered. Red Hat is hiring. They're hiring consultants and solutions architects, apparently in this region, if anybody's interested. But none of them are. No Red Hat people here, are they?
Well, we're all IBM now.
Yeah, all IBM now. But the Red Hat, I think the Red Hat field team, though, all got sucked into Orlando this week. That's where they are. I was really torn as to what to talk to you guys about tonight. And this is the primary presentation I'll give. It's the bit.ly Quarkus Java. We'll spend some time there. But there's some other things I want to show you, only because I spend a lot of time talking about a lot of different topics. And so I'm back into Quarkus mode as of today, and I will be so for another week or so. But prior to today, it was all about Kubernetes, Kafka, Knative, and Istio. That's normally where I spend a lot of my time. So like, I'll show you a little bit of StrimZ just because StrimZ is super cool. Anybody here run Apache Kafka? Yeah, so this is Apache Kafka optimized for Kubernetes. So it's an operator for Kubernetes and all that kind of stuff. I'll just show you guys briefly that because that's something I spend time on. And all things Kubernetes. And then, of course, I run these 3 classes now at O'Reilly. So there's a Kubernetes Basics class, an Istio class, and a Knative class. Istio for the service mesh technology, Knative for serverless aspects on top of Kubernetes. And of course, from a Red Hat standpoint, we run all this on top of OpenShift, which is our distribution of Kubernetes. And so the reason this is important is because it actually formed a lot of why we did Quarkus. Okay? So let me just kind of run you through a little history from one of my other presentations that'll hopefully give a little bit more historical perspective. Okay? From 1993 was when Red Hat was born. So Red Hat is actually a fairly old organization. A lot of people don't realize that. And it shipped in 1994, this thing called Red Hat Linux. It's because the guy actually wore a red hat, right, back in his college days, and that's where it came from. And it was just born out in North Carolina off the college campus there. And, and it became a multi-billion-dollar enterprise over time. So it actually is one of North Carolina's most famous startups, if you will, because it ended up being worth a lot of money. Out of Atlanta, you had JBoss. Right? And so JBoss was acquired in 2006. I was acquired as part of the JBoss team in 2006. That's why I was part of this local ecosystem. I have since moved up to North Carolina, though, as part of Red Hat. And now we are all been acquired by IBM. And so us JBoss guys, we're having a little fun with that. We actually say that JBoss acquired Red Hat in 2006. And we kind of took over and made Red Hat more like JBoss. Now we got to do the same to IBM. So it's only 300,000 people we have to infect with our disease, but it could be pretty interesting. But so a lot of people, though, think Red Hat is all about Linux. And certainly we love Linux, right? So Linux is definitely something we come from, but we're not only Linux. And so that's something that's very important to understand. At the end of the day, we're all about Linux, for sure. We love Linux, but we really love this thing called Kubernetes. We call it OpenShift, and we're very much focused on Java. Okay? And so here, I just want to get to a key point, though. Yeah, let's kind of skip along here. Yeah, this right here. This is a presentation. You can look at the link at the bottom and go check it out. It's actually a demonstration I did in 2005. We'll let the thing drop there. But it's on YouTube. And so in 2015, in 2015. And basically, this is when we gave birth to Kubernetes as a supported enterprise solution to the market. So Kubernetes itself was an open source project that Google gave birth to with the Red Hat team in 2014. And as of 2015, we brought it to market and said it's officially supported for our customers. We have customers here in this room already that do OpenShift, right? We have customers all around the globe. But when we gave birth to it, we wanted to figure out a way to let the world know why this Kubernetes thing was so awesome. And it was based on this concept of the Linux container. And why was that so awesome? And so we actually launched 1,026 containers live on stage, 1,026 application servers in front of the audience in 2.5 minutes. And then we let the audience actually claim a container. So on their phone, they could put in an image, and we would use that as their flag to plant the flag on their actual Linux server, their Linux container. And then yes, you were able to draw the doodle with your finger and I still run that presentation from time to time. People do some fun stuff, right? And you have to be careful of what some people might draw. But we did this in 2.5 minutes, and it was a hard thing to pull off. And we could only do this with a Node.js-based server, an application server. We could not do it with a Java-based application server. Way too big, way too slow. Ever since that moment, we've been thinking about this problem. Since 2015, we've been all about Kubernetes at Red Hat. We've been all about Linux containers and Kubernetes. Yet everybody was thinking, we have to move to Node. We have to move to Go. Maybe now they have to move to Rust. But Java's too fat and slow. We heard that time and time again. So I was meeting with customers all the time. They're like, we're going to do microservices. We're going to run on Kubernetes and OpenShift. Yeah, but Java's too fat and slow. So what are we going to do next? And I really have had lots of conversations with people who are like, we're going to retrain 300 Java programmers next week on Go because Java's too fat and slow. Or we're moving all these microservices to Node.js. And so it became a problem within Red Hat, right? We noticed this, especially us XJBoss people who are all Java people like me. We're like, well, maybe we can make Java not so fat and slow. And that's really what we did here, okay? So let's kind of walk you into this presentation, and then hopefully it'll make some sense. And then you'll see what we did, and then you guys can decide for yourselves, is it that much cooler or not? So this is my version of Duke here, my Supersonic Duke. And actually the tagline, by the way, came from Supersonic, right? So I'm going to make a supersonic man out of you. I'm going to make a supersonic woman out of you. If you remember the Queen song. Yeah, I watched the Bohemian Rhapsody. I got into it, and so I came up with the tagline. So this right here is an interesting statement, right? My Mark Twain Duke. My wife, of course, did the design for it, like she does a lot of my design work. But the reports of my death are greatly exaggerated. So I actually went back, and it was actually 2006 when I could find the first documented reference of Java is dead. So we've been talking about Java being dead for a long time. So when I was looking at all these customers who are like, we're going to do microservices and Java's too fat and slow, I kept thinking, well, this sounds like the same old refrain, right? Java's just, something's wrong with Java. And so the crazy thing is, Java's doing incredibly well. It's still #1 as of 2019 here, and actually the latest one that just came out still has Java as #1 in TIOB index. RedMonk puts Java right up there at C++ and JavaScript. Even HackerRank, which is where the cool kids hang out, put Java in the #2 spot, right? JavaScript #1, but Java #2. So Java is doing incredibly well. Java still runs all the major systems in the major banks and airlines and travel industry, big government, you name it, it's still Java. Java is really what's going to basically carry the rest of us, most of us, to our retirement. Think about that for a second, okay? I've been doing Java now since 1996, 1997. And I probably will finish my career doing Java. And it's kind of crazy to think about it. So Java's doing incredibly well, but there was a challenge with Java, right? One of the reasons Java does so well is because it has all these awesome frameworks, all this awesome technology. And that's actually the issue. Java, the JVM, is not necessarily slow. Java, the programming language, is not necessarily slow. It's the frameworks that are slow, okay? So it's all those frameworks throughout the ecosystem that actually make it so much slower, all those utilities and things on top. So once you basically start consuming all these things, all these wonderful flavors from the ecosystem, our Duke puts on weight. It does put on weight. The reason the JVM takes so long to boot up is because all the class loading, it's basically scanning the file system and finding all these things littered on the hard drive and loading them into memory. And then it's scanning them using, basically looking at the metadata, all the annotations across all those jar files. And it's building up its little meta model. And by the way, this memory can't even be reclaimed, right? It doesn't get garbage collected. And then you have your running application. So all that file scanning, annotation scanning, loading, class loading, and of course metadata loading takes a lot of time. It just takes a lot of time. And so that's really where we focused. And so specifically what we found is when we made Hibernate, which we're the people who are behind Hibernate, when we made Hibernate work this way, we thought we were onto something. Hibernate is easily one of the biggest frameworks, and at one point, one of the heaviest frameworks on the planet. As a matter of fact, one of the things that the Hibernate engineering team will tell you is like, Hibernate, when it boots by default, it looks for XML files and tries to parse them by default, because that's the way Hibernate used to work. Remember the HBM files, right? It's still looking for those things. Well, if everyone's using annotations, what's it looking for XML for and trying to parse it for? So there's all these little optimizations that can be made that make everything vastly faster, okay? So that's really the trick. Now, we really got this figured out. Again, when I told you about that demonstration I worked on, we launched 1,026 containers. Well, also shortly thereafter, we did start putting Java in those containers, and Java kept blowing up. Okay, if you don't believe me, I have a whole video on this concept and a blog. By default, Java blows up in a Linux container. And it blows up because it tries to use all the memory on the hardware and all the CPU on the hardware. Because Java was built long before there was a virtual machine, long before there was a Linux container inside that virtual machine. And therefore, it thinks it owns the machine by default. Now, this has been fixed in Java 9, 10, 11, and it's being backported to older and older versions of 8. So it's likely, if you're on Java 8, that you're probably okay now. But it depends on the specific minor release of Java 8. Like if you go back to 151, doesn't work. All right? So you have to be in the 200 range, so 1.8 to 12 or something like that. Then you're probably okay. But just be aware of that, because you're going to see when you put in a Linux container, Docker Linux container, Kubernetes Linux container, you're going to see OOM killed a lot. Okay? OOM killed. That's your signal for, my Java keeps dying. The good news is in a Kubernetes world, it gets restarted automatically. Okay? So I've had a lot of managers, senior IT managers, like, this is awesome. I want the Kubernetes because my programmers suck so bad. They keep blowing up the JVM. It gets restarted automatically. And Kubernetes has another special feature. Anybody here ever been burned by the concept of a thread pool or a connection pool? And maybe you didn't have the finally block figured out back in the day, so you kept pulling things out of the pool, but you never really put them back in if an exception was thrown. Anyone had that issue? Anybody had to consult on that issue? So when I was a consultant, Mark was a consultant with me for a while, right? Yeah. Sometimes you have to go into a customer and figure out what the hell, the JVM is locked up. Yeah, if all the threads are gone from the thread pool, it can't respond to anybody. And Kubernetes actually will see that and shoot it in the head, kill the zombie, let it restart. So there's a lot of things that make Kubernetes so much more interesting. So you'll have to go back and watch one of my presentations called Kubernetes is Your New App Server. And I compare it to app servers of old, because that's essentially how I think of it, right? It's basically clustering. It takes care of all the management stuff. But when we put Java in that container, and we lock it down with this thing called C groups. That's basically what's happening underneath the covers. It's a Linux kernel thing. So this is a Linux thing. It's not a Docker thing. It's not a Kubernetes thing. Basically what happens is Java goes boom. So this was another signal to us at Red Hat. It's like, there's a problem. So we patched this issue. That's what I was saying earlier. It's been patched in 9, 10, and 11, and it's being backported and patched to 8. We've been working with the Oracle team to get the roll out of the patch to more people, because we have customers suffering from this issue. But when you start blowing this thing up to a lot of containers, you really, really notice the fact that Java really doesn't like being constrained. Java really wants to get outside its cage, and Java really wants to use a lot of memory and CPU. And again, customers were telling us, can't we just move everything to Node.js, or can't we move everything to Go? All right? And so it's a problem. What I want to do, well, actually, let's show you this next bit, just because it's funny. It's not going to be funny for you as Americans. It's really funny in Europe. So 1999. 1999 was an awesome year. The U.S. won the World Cup. You guys remember that? Even Americans don't remember. And in Europe, people start going, right? They make ugly noises. They're like, what, Americans? They don't even know what a World Cup is, right? We did win the World Cup. So, everybody needs to go check their bias. They just won again. Yeah, they just won again. So it's funny because it's really funny because no one realizes that there's actually another group of people who play this game at the World Cup level. So, but the point of 1999 is really this. I've done this presentation for a number of years, but if you actually had to build a Hello World in 1999, I don't see Mike here, but Mike helped me do this research. He used to be part of our Java community way back in the day, but he worked for Sun, worked for Oracle, so I had him go back in the old price books, okay? So I was a consultant doing WebLogic work in 1999, and so I had customers where I was basically, and Mark, you were teaching, I think, back then too, right? We were teaching Java and things like that, and in order to get a project started, this was the startup cost, okay? The startup cost. And this is where, and I had people, and I'm teaching Java, Mark was teaching Java, and we were basically going to the customer and saying, look, your 10 programmers need decent laptops, with like a gigabyte of RAM. They're like, no, we can't afford that. Why can't you afford that? Because we spent this. And so look at even the Semantic Cafe, it's $50,000. IDEs used to cost a lot of money back in the day. So my point is, we used to spend all this money, and we would basically put an RFP process together. It took 6 months, and we would land that into the data center, and that's where we wrote our Java apps. And and if the company was too cheap, all we had was VI and Emacs to work with, and all we had was a terminal VT100 or 220 because we couldn't afford real laptops at this point in time. This also was back when Microsoft's JVM was the best JVM as well, so it was a little different world. But the that concept, I mean, you had to think about things very differently. We used to architect around this issue. I knew people who would basically use special versions of WebLogic to save money on WebLogic, or they would basically not spend money on the IDE and all this sort of thing, trying to cut these costs. But this was when Java owned the machine, okay? So now, I want you to think about that. Now you spend so many cents per minute, right? This is the kind of world you live in now. We now think about these costs. That $500,000 was a sunk cost. We spent the money, it was gone, everybody was happy. The data center operations team, the IT manager had a bright, shiny box that they could point to, they were very proud of. You couldn't put software on there because no one could actually write the software at the time, but at least they had a bright, shiny box. In the new world, you know, we're spending $5 a month, $10 a month. We're spending 10 cents an hour. But what's happened is it's no longer a CapEx, capital expenditure, it's an OpEx. We spend it every month. Now people notice when we spend money on memory and CPU. So less CPU, less memory, people are noticing. So that was another impact, another thing we had to think about as it relates to our customers. Again, Java was born, you know, way back here in 1996. You can kind of see Red Hat Linux was around in 2000. That's Red Hat Enterprise Linux, by the way. So the KVM and things like virtual machines and the cloud was 2006 here. You know, we had the Fat Jar with Vertex and Drop Wizard in 2011. We had Netflix born in 2012, right? We had microservices born and started to be talking about in 2012. And then Docker, Spring Boot, Kubernetes, all born in this little magic time window here that kind of changed the way we think about how we build software in the Java community, right? So if you think about the Docker Linux container, Kubernetes, Netflix showing us a whole different way to build applications, Spring Boot, Drop Wizard, Vertex showing us this new Fat Jar architecture, right? Doing things like that, where you didn't have to have a WAR file, EAR file. Things really changed a lot, okay? And so I make that point because we had to think about this as it relates to making this thing work. So let's actually show you, kind of show you this thing here, okay? And this is actually an old slide deck, so I'm not even sure what the data looks like now. But if there was a way to take what people build in their average application, so your average application at this point probably is a REST endpoint. Get, put, post, and delete on a REST endpoint at this point in time. And it probably talks to a database, relational database still, but also a NoSQL database. It probably talks to Kafka now, right? You know, so can you make all that? Can you make that application stack super small, super fast? So like in this case, you can see it's a 13 megabyte RSS. RSS is the actual memory being used. Don't look at the disk footprint. That doesn't matter at all. Okay, how big the file is on the drive doesn't matter. It's how much memory is in use at runtime is what matters, as well as how many CPU cores are required to make it run successfully. Because those are the things you're paying an Amazon bill for, an Azure bill for, a Google bill for. And so we really focused on these things, like how to do CRUD-based operations, create, read, update, and delete against a database. And then, and it really kind of made a big difference. But let me just show you a demo. Let's see what I can make run here. And it'll make a little bit more sense. Let's see. Not that one. Yeah, can I do this one? Yeah, let's see if this will work for me. I have all this stuff going on. I sometimes don't remember where it is. But I have a mini cube here running a little base Kubernetes. So let's do kubectl, create namespace. Let's just have a little fun here. Let's call this Ajug. I'm just kind of making this up as I go. Not get, create. All right, got to create one. Cube and S, Ajug, let's make it sticky. kubectl get pods. There's nothing running inside this little Ajug I just created. So we can just have a little fun with it. Let's actually run a little Node.js application. So I'm going to say kubectl apply, kube control apply -f, kube files, and I have this is a Knative service. So let's see if it comes online for me. Yeah, let's do this. Let's just watch. There it is. It's coming online. So basically, in the case of a Knative-based pod, right, it only wakes up when it's needed, and then it goes away. All right, so it's that serverless architecture. It's the concept of you have an event, we wake up, we handle the event, and we shut things down if no one's sending events. And so you can see this is my little Node.js I just brought up. If my little poller is working, let's see here. There we go. There's my little Node.js. Okay. Here's the same for, I'll just do the same for Quarkus here, just so you see it. Apply -f, kube files, and then kn service. Okay, I made all the file names the same to make it a little bit easier for myself. And then and I even have one for Spring Boot, right? So, and I have a bunch of others. So if you look in here, there's Python, there's Go, there's .NET Core, just to try different things. Because it doesn't really matter. Kubernetes is language agnostic. It doesn't care at all. But you have to bring these guys up. You can see it needs to go 2 by 2, right? So the 2 by 2 is when it's truly ready. And once it's 2 by 2, then you can start interacting with it. So if I basically just say, let's pull it. I have a little script that basically allows me to pull it easier. Come on now. Wait, where is it? Oh, KN poller. All right, okay. Get that going. Get that one going, and the Spring Boot one is ready too. KN poller. But and this again is just an example of what you can do in this Kubernetes world, right? So deployment of your application into this clustered environment, we don't have to do it app servers anymore. The cluster is this Kubernetes thing that is basically managing a bunch of computers on our behalf. And as long as there's CPU and memory on one of those computers, it takes your workload, your application, and moves it and runs it over there, okay? Runs it across the different cluster nodes. So that's all I basically said was, hey, just run my Quarkus app, run my Node.js app, run my Spring Boot app in this case. If I go back over here to kind of make this point, okay, just to kind of see what we're dealing with here. So Kubernetes has this concept of a master with etcd, a scheduler, an API, and then has these worker nodes where you put on the worker node your Tomcat, your Wildfly, your WebLogic, your COBOL application, your Fortran application. It doesn't matter what it is. Your Spring Boot application, your PHP, you basically add it to each of those nodes by simply making a simple declaration. So you basically say, here's my Linux container image, Quai.io images. I want 2 replicas of that. Give it some labels, things of that nature, and it basically makes it happen. So you can see my 2 little Tomcats appearing down here. All right, so my 2 little Tomcats show up. And it's also being very clever about this. If anything dies, like let's say this Tomcat dies, right, it knows to basically move it someplace else. Well, it doesn't move it per se, it just recreates it someplace else. Another way to say it. Respawns the zombie that died there, right? So that's the beautiful thing about it. But because of this dynamic aspect, it does matter how long it takes to run and how much memory it uses. Because Kubernetes is trying to optimize the use of these CPUs and memory over here and bin pack. Maybe you've heard that phrase before. If you've ever been in a big old warehouse, right, they have all these bins they store everything in. And they don't want bins semi-empty. They want bins fairly full. And they want to optimize, right, where they put things so they get things fairly full. Kubernetes is trying to apply the same logic. It's trying to get things fairly full, so it's taking advantage of all the CPU you're paying for and all the memory you're paying for. And with Quarkus, because it's so small, yeah, you can fit 20 of them in the same space you have 2 JVMs. Okay, so that, kind of be thinking about that. So, I mean, let's kind of show you this.
So what's the relationship between Quarkus and Kubernetes?
Well, Quarkus is based for Java developers. Kubernetes is for everybody, right? Python developers, Go developers. Quarkus doesn't help you if you're a Python person, okay? And you'll see that in a second. But while I'm here, let's also have a little fun with this. kubectl. I just want to show you this other thing because one of my favorite projects right now is called stremz. I mentioned that earlier, right? So this guy, and that's Kafka and Kubernetes. Let's see if this will work for me. Let's see here. Let's go here. I'm going to basically just grab a YAML, if I can find it, from one of my examples here. Yeah, I think this one. No, maybe not this one. Yeah, this one, okay. And so basically, I'm just going to grab a YAML file. If you look at this YAML file, it basically says, I want a Kafka. So one of the things that's really awesome now about Kubernetes is you can basically say, I want pizzas, Kafkas, anything you want. All right? The schema is fully extendable now through this concept of a custom resource definition. So I can basically say, I want Kafkas, and I can make Kafkas happen. It's pretty awesome what's happening here. So it's even way better than the old app server if you think about it from that perspective. Right? So if I say I want kubectl apply-f and paste in that URL from that YAML file, and if I did things okay, kubectl get Kafkas, I now have a Kafka cluster also coming online. And so a proper Kafka cluster is basically, that's running off the screen a little bit, is basically 3 zookeepers that have to come online first. So that's what you see happening there. And then it has to have 3 brokers, because that's the proper way to treat Kafka, right? 3 zookeepers, three brokers, and then you'll see the little operator come on board. But you can even see that I can do something like called kubectl get Kafkas. So again, this is all the world that we're living in at Red Hat and been thinking about. And so how do we do something kind of more interesting with this? And how do we bring Java into the game? How do we make Java ever more efficient kind of thing? Because this dynamic aspect of always just loading and unloading and moving is part of this Kubernetes world now. Let's take advantage of the resources that we have. So you can see there's my Kafkas coming online. So I've already done Kafkas. I already have Kafkas out here, kubectl get Kafkas on this, and this is actually a real cluster, kubectl get nodes. Okay, this one is just a little bitty thing running on my laptop, a cloud on my laptop. This is for real. Okay, this is has 9 worker nodes in it. Now these worker nodes are tiny, 2 CPUs, 8 gigabytes of RAM. They're smaller than your laptops. They're like Raspberry Pi worker nodes, right? They really are not much. But I did that on purpose. You can pick and choose what level of CPUs and cores you want there, only because it's more fun to see this thing have to go through its process. So there's a Kafka running here, but I've also set this up with Knative eventing. Let's see, let's go ahead and run my loggers so we can see what's going on here. And I think this is running over here. Yeah, where is it at? Bump, and here. Yeah, everything's kind of weirdly shaped now that we're on this projector. But here's a good example of where it really has to scale. So all I'm doing is pushing in 100 messages into Kafka right now, and I'm basically trying to get a Quarkus-based app to respond to that. And it had no pods running, no app running, no memory in use, no CPU in use, but basically it has to start scaling up based on demand. So let's see here, this guy right here. Come here, all right? And this one over here. There we go. Oh, my UI has died. Come on, refresh the page. It's probably got disconnected when I reconnected. Yeah, so it's actually doing its thing. So literally right now, it started 43 app servers, like that. Application servers. We're not talking, you know what I mean? The whole app came up, 43 of them. And it's trying to get to 60. It actually won't get to 60 because I've constrained everything else around the system. But it's doing that across those 9 computers and those 9 worker nodes in the cluster. And so you can kind of see they're coming up here. See that pending one right there? That actually is an indicator to me to know that I'm probably out of cluster resources. So it wants to get to 60 based on the load I sent in, but it can't. There's no more bin packing to be done. We've used all the available capacity.
Watching the Kafka to generate these.
Yeah, this is something known as Knative, right? So Knative, one of its jobs, kubectl get Knative, get CRDs, grep Knative. Knative is yet another thing I've added to this cluster, and it has the concept of serverless services. And the point of Knative is to say, if you have a pod that's not in use, shut it down, give that memory and CPU back to someone else, pay for only what you use, but if a burst of traffic comes in, scale, 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 scale. It's a very clever project on top of an OpenShift cluster or Kubernetes cluster, and that's what I'm running here. It's basically this Knative serving and Knative eventing, and there's also a Kafka here, right? Kafka sources, Kafkas themselves, right? These are all part of the equation now. And it looks like it's starting to downscale. Yeah, so basically the load is over, so it started shutting everything down. If I add more load, we can go a little bit crazier. Let's add 1,000 concurrent requests, see what it tries to do. But, so basically it finished its previous load, and now I'm shoving in a bunch of new load. But again, the point of this is we were looking at ways to how to make Java apps scale super fast. Because again, customers are like, we got to have the scale issue. We can't do it with a regular JVM. Now, here's something to think about it. A JVM is awesome when it can live for about 12 minutes. That's what we've been verifying. So we have the OpenJDK team at Red Hat. We have the Hibernate team. We have the JBoss team. We have all these teams that use Java for lots and lots of customers and massive production capacity, right? So we see how this thing behaves. If a JVM lives for 12 minutes, it's actually going to perform very, very well. But it needs to live for 8 to 12 minutes. In this case, these things only live for about, 60 seconds. So in this use case, you need kind of a different thing. All right? So we'll show you that. So in this case, it's getting up to 43, though I'd want 70 in this time. And 43 is about the highest I can get on the cluster capacity that I have. Okay? But 43 app servers trying to get up there. And let's go back here. So let's actually kind of show you what a Quarkus-based app looks like. So what's the easiest way to do that? This is the Quarkus website. This is code.quarkus.io. All right, so you can basically use this as a way to come in here and say, oh, I want to put in my, Burr, Sutter, Ajug, and I can start, I'll call this the Ajug artifact, and I can say I want things like, I want Postgres, right? I want to maybe Postgres. I want REST by default is built in, so I don't need to worry about that, but I might want JSON-B, right? So I'll pick JSON-B. I want different aspects, so JAX-RS is built in, things like that. Maybe I want this thing called Panache. All right, that's one way to get your project started. I'll show you another way to get the project started. That's a little bit more fun. All right, let's actually start another project here. So mkdir Ajug. All right, Ajug. All right, I'm going to create. I have nothing up my sleeve. It's just a big empty directory right now. Okay, so we're going to go in here, and I'm going to basically just run this command, and it's just a Maven plugin, right? So you just have to have Maven on your machine. And you run this Maven plugin. It's not an archetype. It's right. So a lot of people ask about that. It's not an archetype. It's a different feature of Maven that has been around for a while. So let's call this thing Sutter Ajug. Yeah, 1.0 snapshot. Let's add the REST endpoint for Hello World. Yep. Let's go ahead and do that. Let me bring it up in Visual Studio Code. Code space dot. Visual Studio Code is my new favorite. If you guys are unfamiliar with Visual Studio Code, Red Hat with Microsoft did the language support for Java there, right? So that's a Red Hat contribution. So Java is what we work on with Microsoft on Visual Studio Code. This is all free, runs on every platform, Mac, Linux, Windows, that kind of thing. It is not the thing that used to cost a lot of money called Visual Studio, just happens to have a similar name. But it's much lighter weight. And look, if we go in here and basically look at this piece of Java code, this is what it looks like out of the box. And this is JAX-RS. How many people are familiar with JAX-RS syntax? Okay. And I know for some of you, it looks a little odd. I'll show you something else in a little bit. But right for now, just go with me. We have this concept of a URL path, and we have something called a get, or a post, or a delete. Right? It's pretty, once you know that it's get, put, post, and delete, and there's paths, you got it. JAX-RS is not that hard to learn. But I know a lot of people don't know the syntax, so let me actually, but have a little fun with this. I'm going to go here now. All right, let's do a terminal. And I'm going to say Maven compile Quarkus dev. So one of the things you do with a Quarkus-based app is it has a dev mode, right? So you should throw it in dev mode and live in dev mode as much as possible. And because what that means is now I can come over here and basically say curl localhost 8080. All right, and that's the web page there. And this is hello, the thing we were just looking at. See, it says hello. And I can also bring it up in my browser. Let's just do that. Localhost 8080. It's cached something. There we go. And hello. There we go. All right, so hello there. And so I can come in here and make changes now. I can say things like, oh, let's just make it say bonjour. And you hit edit, save, refresh. Okay? So edit, save, and refresh. Edit, save, and refresh. Remember those three words. It's a game changer. Most Java people are like, wait, hold on. I got to do my Maven build, and I'm going to go get coffee, and I'll come back. Well, you don't have to do that anymore. Edit, save, refresh. Now, for Java people, looking at it like, this is just weird. I know, it's weird stuff. This is what Node people have been doing since the beginning. It's why they're so much more productive, right? It's really funny, guys. I show this to Node people, and they're like, really, you Java people just now figured this out? Like, yeah, we get coffee a lot. Yeah. Yeah, so I'll make it say aloha here. Edit, save, refresh, right? Make it say whatever. We're in Georgia now, so hey, y'all. Make it say, hey, y'all. There we go. Edit, save, refresh. But let's actually take that to another level. Let's try to make it a little bit more fun. All right, so I'm going to come back over here and just do something simple. Earlier, I showed you I could add the libraries that I needed from this user interface. I'm going to do it from the command line, though. It's more fun for me. So Maven, Quarkus, list extensions. All right, so these are known as extensions. These are libraries that have been optimized for this new world. Okay? In other words, we've gone in and optimized these things. You can actually use anything that runs in Java, no problem. These are optimized to be small and fast. Okay? And this, in other words, this is Hibernate, ultra small, ultra fast. This is not the big old Hibernate. This is Hibernate that knows it needs to start up quickly. It does everything the old Hibernate does. It just doesn't scan the file system, doesn't parse XML files. But if you need that, you're going to have to go back to the old one, right? But if you don't use that, if you just use annotations, you don't have to worry about it. So let me come up here and basically say add extensions, and let's go ahead and pick something. And actually what I'm going to do is, what do I want here? I'm actually going to pick the Hibernate that is known as Panache. So actually our Hibernate team has invented a newer, friendlier Hibernate. So we're going to show you that. So we call that Panache. There's Cogito, which is based on the Drools project. So that's your DRL, BPMN2, if you're familiar with BPMN2 or DRL syntax. I want to get the Postgres because I want to talk to a Postgres database. Let's add that one. And then I also want the JSON-B, where'd it go? So REST easy. We'll take the REST easy JSON-B, okay? Because REST easy is the JAX-RS implementation that's built into this. Let's do that. All right, add those extensions. Bring up our editor again. It was already open. I just had to go find it. And look at the POM XML. It's been updated. Okay, POM XML has been updated. And now it has the JSON-B, has the Postgres. So basically it just has jar files. That's all we're talking about here. But they're jar files optimized for this new way of work, if you will. All right, so let's go here and start building our app. So I basically made it so I can do a database-driven application with JAX-RS, right, a RESTful endpoint. So if I come in here and say I want to do a to-do.java, this is a new class. Let's add a new class. I want this thing to be an entity, right? So this is JPA, or Hibernate, if you're familiar with that concept. So we want an entity. I want a public string title. This is a to-do app. Public boolean completed. Is it completed or not? Public, and then, in order. Yeah, I had to think about that for a second. And actually, order is one of those things that causes heartburn. So because of the name, so let's actually rename the column. And so name equal, we'll call it ordering, okay, because order is somewhat problematic for a SQL database. And that's what I do, okay? You're probably thinking, wait, where's all the getters and setters? Where's all the special finders? You can do all that, but we can also have this thing called Panache. So Panache, we just simply say extends Panache entity. And all that other magical stuff is handled for us, okay? So let's make sure you do the right import. We hit save, all right? Save, let's see what happens. I don't really know what's going to happen because I haven't tried this in a while. Let's see. Oh, it blows up. Let's see. Why? Oh, you know why? So here's another thing that's really nice about this. Because it's the edit, save, refresh model, much like Node.js, we put the errors in the browser, right? So you don't have to go find them wherever they are, right? We put the errors in the browser. So I did not configure the JDBC driver, which is true. So one of the things we've also done here is we put everything in a single application resource file. But I'm just going to cheat and copy and paste those. There's actually a new Visual Studio Code thing we've done. So you can actually say Quarkus, right, and start prompting you. But I'm just going to copy and paste it for the sake of efficiency. Let's call this thing the DB Ajug. All right, we got it all filled in. Hit save. But I got to go to the database now and add that in from a database standpoint. So let's see if my PG admin's OK here. Let's refresh PG admin, server, the local Postgres. All right, we got to add a login for this, DB Ajug. All right, we're going to use that. We'll give it the same password. We'll just go ahead and just make it a super user so it can create the schema and all that jazz. Uh-oh, it's off the screen here. Man. And I can't hit return. Here we go. All right. And then let's create a database. We made the same problem here too. But yeah, that guy right there. And let's see, got to make it bigger. There, save. All right. It wasn't built for this user interface, this screen. But here's our database. Schemas, public. Let's see, tables, no tables. Tables is empty right now. Let's see, over here, here's our error message. Refresh. It says, hey y'all again, looks like it's happy. Come over here, refresh. And we have tables. And we have columns. We have schema, right? Because that's a Hibernate feature. Hibernate's always been going to generate schema. Okay, so that's not a new thing. The difference is, can we make it optimized for this experience that we want to create? All right, so let's keep going here. Let's go add some more stuff. What else do we want to do here? That's all cool. Let's add the REST endpoint. To do resource. resource. Let's spell resource correctly. Not that it matters, but it might forget what it is later on if I don't spell it correctly. All right, so we add a new class. Let's add path. Let's going to call this thing /API. Just make it simple. This is going to produce media type. We're going to basically produce application JSON because it's going to be a JSON-based endpoint. All right, and we got some imports to take care of there. There we go. And we're going to consume some media type JSON as well. Dun, 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 yeah. All right, very good. And let's see here. Let's do a get, right? So we get from the browser. We'll basically say public, and we're going to return a list of our to-dos. So yeah, list of our to-dos. To-dos, we got to-dos out there. This is going to be the list, all of them. And nice thing here is if we look at to-do, remember that to-do we built earlier, to-do list all. There's a list all on there, which is nice. Okay, and I can return that. All right, and I got to get list in here. I got to get list, yep, Java util list. All right, good. All right, so if I... What's that?
Is that because of the Panache thing?
Well, Panache, I mean, we've kind of had some of these shortcuts built into Hibernate for a while, but Panache you'll see more of. Really, the Panache, though, is really this. We didn't have to declare anything but the base schema, and that was all. You can add all your validation annotations, things like that too, right? If you want it to be numeric or so big or so small, unique, all those things still apply. Let's go here. Where are we at? And it was this one. Okay. It was API. Let's get to the right place. API, and that's just an empty array. Okay, so just an empty array because there's nothing in the database. Let's add something to the database. Post. Post is how we add things. Public response. Okay, yeah, we're going to have a response. Add one. And let's see, we're going to add a to-do item to the database. Okay, again, we get our imports in here. We want the response. Okay, yep, all right. And so we want to basically say item.persist. Okay, we need to make it transactional. So by default, we do basically support transactions in this case, right? Because it is, in fact, like a traditional Java web application, right? And in the case of a traditional enterprise application, you need transactions. And then I want to say return response, because what is the response to the browser that it's happy? Response. And its status, yeah, we're going to do the status.created. So yeah, it's 201. We could do return 201. But there's also a little thing for that. Let's return the entity that we persisted and build. I think I did that about right. Looks fairly happy. Okay. Let's just refresh, right? So your refresh still works, but I need to do a post now. So I could do a curl post command, things like that, or we could use Postman or one of the other tools for doing that. But I have a user interface for this. And the nice thing about this is typically now you work in a world where there is a user interface team, the front-end engineer and a back-end engineer. I'm the back-end person in this case. But the front-end is already done for me. It's called To-Do MVC. So they do, if you've heard of To-Do MVC, it's a group of people that basically try everything under the sun, and meaning every JavaScript library you can think of, and make it to-do app. So this is a Vue.js version of it. So you can look at To-Do MVC online. It's pretty cool. All right, so they have everything. You want to try React, Backbone, Dojo, right, all that stuff. They do it. So this is the Vue.js one. But let me move. I want to basically take the Spring or the to-do app. I'm going to copy it. Let's see if this works. I want to copy it over here to, what did I call this thing? Ajug, right? And source. And it goes into source main, resources, meta inf here, resources. All right, and we're going to paste it in here and replace that index HTML that's there. And let's see what we got. All right, let's go to the root now. We're on root. Okay, here's the user interface. 1, 2, 3. Let's see if that works. Go to my database. And you notice I'm going back to the database user interface a lot here, because this is actually how I grew up. All right, I grew up a long time ago, and when I was programming, the database was a new thing. Okay, that's how long ago it was. And the relational database was absolutely new to everybody. And we were still learning third normal form and voice cod and all that jazz. I know people don't really worry about that anymore, but we cared about it. So I would always go back to the database to see if the data landed there. So that's what I'm doing, right? So 1, 2, 3, my data's landed here. So it's just kind of an old habit. Let me add one more, come over here, 4, Let's refresh, right? And well, 4 is buried under there. Okay, but we're adding data. And if I want to get a little bit further with this, we can keep going here. Let's add a delete. Delete. Let's add a delete. It also needs to be transactional. Let's also public response. Again, it's going to have to response to the browser. We're going to delete one. Oh, in this case, we're going to actually pass in which one to delete. So we're going to basically do this sort of thing. ID. Yeah, I think that's right. Okay, and then so at path param, we basically have to name that parameter. ID, long ID. Let's do that. And I think that's what we need. Yeah, path param. We got to import that, looks like. Yeah, got to get that in there. All right, so now we basically do a to-do. Yeah, to-do entity equal to, yeah, let's do that. To-do entity equal to to-do find by ID, give it the ID, that's what we want. And then we say entity.delete, and then we return response. Let's just do the no content, right? Nothing's coming back. You don't get anything back, it's just deleted. Forget what the exact response code is for that one. Okay, so we have a delete now. Again, I edit, I save, I refresh, right? You guys get the pattern here? 1, 2, 3. Now, where did all my old data go? Let me go ahead and test my delete here as well. My old data went away. I don't know if you guys noticed that. And it just occurred to me that we need to show you that. Come on now, refresh. We've got to refresh, PG admin. All rows. Okay, we're down to 1. So my delete's working. But you notice when I did refresh, my data went away. And here's why. If we look back at my application properties, I have currently Hibernate ORM set up for drop and create. So when I hit refresh, things are being reloaded. It's just being reloaded fast. Okay? So that's part of the magic trick here. It actually is recycling the whole thing. It's just doing it so fast, you don't really notice it's doing it. And that allows you to have this nice edit flow. It's same in Node.js land. If you're a Node.js person, this experience feels about the same, all right? So let's say I have my delete. Let me go ahead and just add my update, right, while we're here. And in this case, for this user interface, it's a patch, but it looks a little bit like the delete, so I'm going to copy that. Okay, it's a patch in this case. All right, transactional. We're going to update one, not delete one here. I'm kind of hammering on this thing, so we'll see what it ends up with. Okay, got to get that right. And in this case, the to-do item itself comes in. Item, okay. So much like before where we had to find it, let's go ahead and find it again. Just paste that in, make this a little bit easier for ourselves. And we need to once we found it, we need to basically just map all its data over, all right? So completed. So from the browser, we're going to map it over to the database item. Like order, item order, okay. Entity dot title. Well, that's the most important part. That's the string itself, okay? And the rest of that's probably fine. Yeah, okay, so return, response. In this case, response, we're going to do a, let's see here, let's do an okay. Yeah, we're just going to return the thing, okay? Because that's typically what happens when you update. You just return the thing that was updated. So save, edit, save, refresh. All right, where's our refresh? Over here. Oh, I did have an error again. Let's see here. See, I have a. That wasn't planned. Edit, save, refresh. Good. 1, 2, 3. Let's go check on that. Okay, let's see, did that go in? All rows. Oh, come on. Refresh. You got to refresh PG admin too. I wish they'd fix that. Okay, all right, 1, 2, 3. And if I come back over here and say, all right, let's see if our update works. I love Java. Okay, I'm going to learn some Quarkus. And I'm going to be awesome. All right, so let's go back to our database here. And there it is. All right, so we have full CRUD capability. Create, read, update, and delete, right? No validation, nothing real fancy here. But you guys get the point. Edit, save, refresh, edit, save, refresh. Build the app, test the app. You can still run test cases too. So like over here, I do have one test that was generated with that hello world endpoint. So if I look over here, Let's see here what it says. Run test. You can run test. You should run test. Run test from the IDE. Run test when you do the Maven build. All your traditional Maven stuff still applies. Maven test, Maven compile, Maven clean. Oh, I have an error. Let's see. Oh, I said hey y'all, right? So it says hey y'all now. Got to fix the test. All right, hey y'all. All right, run, close this. Run test again. So hopefully that'll come out better, right? But basically you build the app. Is that good? All right, good. All right, green. We're green. Fantastic. So go back over here. Now, if you look, we did some things. We have some stuff now. So if I say Maven package, okay, this is now in the traditional what we call fat jar world. But in the case of Quarkus, we don't do a fat jar because fat jars are fat. We actually have a little twist to this. We have a skinny jar. And it has to do with the fact the way Linux container images are created. So if I look in my target directory, ls target, notice there, not that one, this version of it. There we go. There's a fat jar here that's this one right here, 1.4 megabytes in size. That's the whole application. And it's because there's a trick to it. There's actually a lib folder that also accompanies it. The lib folder is my dependencies. In other words, I rarely change Hibernate, but I write new business logic on top of Hibernate all day, every day. So we are basically optimizing those Linux container layers. If you're familiar with how Docker does its layering, we're optimizing that experience too because it'll build the Linux container that much faster and ship the Linux container that much faster. So even that matters in a highly scalable world. When we did that 1026 containers live on stage, moving the bits and layers of the container had a huge impact on performance. And we saw that right away. So we learned that trick too. So if I say java-jar, target, Ajug here, 1.0 snapshot. All right. Oh, it's the runner one. You got to use the runner one. And there we go. Come on, Java up and running. Oh, what did I do wrong here? Oh, I have the address in use. Yeah, I do, because I'm running it over here too. So stop running it there. One more time, run it again. Let's see here, and there you go. So just so you know, that Java-based application started in 1.6 seconds. So even pure Java, java-jar, starts fast, okay? Starts fast, so 1.6 seconds. And again, if I look at my app, it still should be running over here. Okay, well, yeah. No, not that. And this is actually, I didn't clean. So it's still the same application. But let's ignore that for now, because the user interface is missing because I didn't clean. So Maven, clean. Let's clean it, but I want to do something else anyway. Let's package p native. So this is the last tip here. I think this should work. We are leveraging this thing called Grail VM, however you want to say it. Let's actually say it together, right? Growl.
Before you get there, right, the lib folder that you talked about, is the transitive dependency sitting in the lib folder?
I don't know. Let's go look. I've never looked at the transitive dependencies. This one's called Ajug, and then we go into target, and we go into lib, and open. Let's go see. Yeah, look, there's the transitive dependencies.
So because they're sitting here, how does your Quarkus know which layer of the Docker container to replace? Because these things can change.
Now, this is purely the way the Docker files. Now, these things should not change that often, by the way, right? That's why they're separated. These things should not change that often, otherwise your tests are likely to fail, right? Your application is going to blow up because your underlying libraries are changing. So normally you don't say latest when you pull these things. You have a specific version that you validate your application against. Just like Docker layers and just like Maven objects as well, right? Maven artifacts.
The base image should have this thing for this.
Well, not the base image. Yeah, not the base image. It's a layer above the base image. All right, now I would never put this in a base image, but I'd put it in the application base image, right? So there's your Linux base image for whatever Linux you want. Then there's the application infrastructure layer. Then there's your app. And actually, people stratify it more than 3. I'm just making it simple for 3.
You need to set the install that second layer for apps for a given release.
Yep, that's what I would do, based on what I'm validating my application infrastructure against. Whoop, I don't want to mean to go Slack there. All right, no Slack.
Would you add another layer in between if you did have something like some internal dependency?
Oh, totally. Yeah, people, I mean, on average, I'd see 6 layers or so, right, for these Docker layers. For instance, you have the JVM layer if you have a JVM. But what we're going to do now is we're compiling it's in native code. We don't need the JVM anymore. Okay? So with this thing called Growl VM, all right, so you can go to downloads, you get the community download from GitHub, and this is, I literally picked up the new version today, so I'm using literally this 19.2.1 right now. And based on that, it has a feature called native image. And if you've optimized your applications the way we have here, you can compile them to native code, okay? Because by default, in this new world where things start up fast, don't have to scan the file system to load everything. We don't have to look at all the annotations to build up the meta model in memory. In other words, use reflection for all that sort of thing. We ignore all that. That's all gone. It's all done in a closed world way now. In other words, all that stuff that happens automagically that normally happens at runtime is happening right now. It's happening at build time. And actually it just finished building, right? So it actually took, what, 60 seconds or so to run that build, maybe 90 seconds? It's basically looking at the holistic version of that application and every dependency it needs, including what we just discovered, because I actually didn't think about the transitive dependencies, but even all the transitive dependencies, come on, right down in here, all these guys, all of that has been analyzed now and pulled into a single executable, okay? The whole JVM in a single executable. So if I say LH here, target, let's go check it out. It is this 54 megabyte thing. 54 megabytes, the whole application, the whole CRUD-based app.
So you went through a consider dependencies, processed all the annotations, the static. How does it process runtime annotations? It doesn't know.
Nothing here is runtime anymore. Everything's compile time now. Did you see anything runtime in my code?
Your code may not have that, but if you do,
Yeah.
then,
This is not for any old school WebSphere app that you have, or JBoss app, or so I work for JBoss, right? So the JBoss customers we told it's not for you. It's not for you WebLogic people or WebSphere people. It's people who build net new Java applications the modern way. Okay, and so if you actually can use reflection. That's a misnomer. You just have to declare your reflective needs. And so there's actually an example I have in in other words, because it's still a closed world. You can use reflection, but you have to say what I intend to loop through, if you will, and process.
but this is only applicable if you want to use the Growl VMs.
Yes, if you use the JVM-based approach, no problem. And you get the 1.6 seconds. So that's already a win. That application in a normal JVM is 8 seconds startup, right? In a normal mode, that's about a 6 to 8 second startup. In this case, it's 1.6 seconds on the JVM. Let's start this one. I don't know what I'm going to get. I haven't tried it. All right, it started in 0.038 seconds. And that includes connecting to the database, generating all the schema, building my connection pool, and having the whole app ready to run. The whole app is ready to run in 0.038 seconds. So here we can go play with it. Yeah, this one over here. All right, that one, right? It was hey y'all. And let's see if it picked up the right page, because I was having some problems with this earlier. Yeah, come on. There we go. 1, 2, 3. I misspelled it. And go back to our database. Let's see here. Refresh. And, yeah, dun, 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 dun. And there we go. I misspelled 1 even, right? So yes, the whole app is launched. You can even see I have it set up to it generates the SQL for me from Hibernate. So you should turn that off and make it faster.
Is it feasible to use in something like AWS Lambda?
Yes. So we actually have a number of people using this with AWS Lambda. By default, you don't normally use Java with AWS Lambda because for these kind of issues. Though I have to admit, it's not where I want it to be yet. We need to make that a little bit easier, a little bit smoother, and we're working on that. But yes, we already have customers in production on AWS Lambda with Quarkus because it's that much faster than anything else.
Have you ever timed CPU consumption and memory consumption with Growl VM and without Growl VM?
What do you mean?
Without memory consumption at startup and the CPU consumption at startup.
Yep.
With the Growl VM approach and without the Growl VM approach.
Yes. So it might, I don't know, we have it documented someplace. But we have all those benchmarks. I thought it was here on this page, but I think this is just, with this is just, well, you can kind of see it. Here, this is with Grail, 0.014 seconds, with JVM, 0.75 seconds. So that's the with Grail, without Grail. And we definitely have customers already that are without Grail. They're like, you know what? Yeah, we can make this thing sub-second, but we don't need to go that fast. Okay? Some people don't need to go that fast. And, you know, because, I mean, you saw this crazy thing I did over here, right over here, right? You know, if you don't need to launch all these containers simultaneously, right? You don't have to go that fast. But this is an extreme case, okay? I'm launching dozens of servers at the same time. So not everyone needs that. I respect that, right? You see it brought those up really fast. So those are whole application servers coming online. When you see it go running there, it's running, it's serving, it's processing user transactions. But the nice thing is you can downscale it all and scale up rapidly based on load. It's kind of the point. Let's see, let me think here.
Sorry, one other question. So the GraalVM-based container or the image, sorry,
Yeah.
how much of space reduction did you get for that? Because I think you can throw away all those.
Oh, as far as, are you talking about memory or disk? Oh, well, the disk doesn't matter, right? Because the disk is cheap. So you do get a dramatic disk reduction because it was a 54 meg file versus the whole JVM, which is several hundred meg. So on the disk footprint, you get a dramatic change, but disk footprint doesn't matter if you layer your images correctly. It does matter if you layer your images poorly, because I've been burned on that one.
The transitive dependencies, if you don't do the GraalVM, can still keep on piling up, adding to your final disk space on the image.
Yeah. Your lib folder will continue to grow as each thing you add to your POM XML. That is true. Let me see if I can do this though. You guys are being patient with me. Let me try something. Where am I at? kubectl get namespaces. Okay. I was hammering on this thing earlier, so let me try something. This is literally how I work, by the way. Hold this. Set env AWS. I brought this new server up, so kubectl get namespaces. Is this the right one? Yeah, that's the right one. Okay, so let me copy this. I rebuilt the entire cluster, sitting in Chick-fil-A over there across the street. You know, because Chick-fil-A's Wi-Fi works fine. I rebuilt the entire cluster. That cluster you see doing all this crazy stuff here, I rebuilt it entirely right before I came over. So what I want to do, though, is I want to show you something a little bit different. Where'd it go? A little bit different, okay? kubectl get pods. Oh, create namespace. Let's do what we did before, but this is a different cluster than I did before. So let's try the same thing. Ajug, kubens ajug, kubectl apply-f, kube files, can service. I just did this presentation yesterday at All Things Open, so that's why it should still be working. All right, we're bringing our Quarkus app up. Okay, let's bring our Node.js app up. Let's run our Polar so that once it comes up, you'll see it responding, but it's not yet up. Okay, and so this is on that same system that I'm running all that other crazy stuff too, right? So it might be a little bit overloaded. So the good news is Knative has now shut everything down. So these guys should come up. You would actually see it if I was overloading it on one side. You would not be able to get these pods up because literally the cluster is full. These are only 2 core worker nodes. So my Quarkus is up now. Come on now. kubectl get kservice. So this is the URL for it right here. So it's a publicly addressable app. So that's what it's doing there. So why is my Polar misbehaving? Okay, I know what it is. Let's go fix the Polar. Because I think we changed that. Yeah, did we? Yeah, but I think. Oh, you're right. I just made this one on the fly, didn't I? Ajug. Didn't think about that. Yeah, look at that. Thank you. There we go. All right, so that means I got to fix this other one too. I just want to show you this though, because sometimes I show this, sometimes I don't, but I don't even know what I'm going to get. I have no idea what we're about to see, but we'll give it a try here. Ajug. Okay, so let's get this one going. Got to get it quickly before it terminates. What did I do wrong here? So Ajug, that should be it. Echo K service. We're just live debugging here. Yeah, that's the right one. Oh, I edited the wrong one. How about you edit the correct file? That helps. This is what happens when you move too fast. Okay, so here we go. So this is running on my real cluster. Let's see if we can go check it out. This is my real cluster here. Okay, it's got all kinds of cool stuff. You know, it's got the Knative, it's got the stremz, the Kafka, all that crazy stuff you saw earlier. But I just want to show you this, if this will work for me. We're kind of just live hacking this. It has a Prometheus built in. I just need the right Prometheus string from one of my other tutorials. This is one of the classes I teach is Istio. And I keep this string over here in this little class, observability, Prometheus, container memory, and I passed it. There we go. This is PromQL, I think is how they refer to it now in Prometheus universe. So I call this thing Ajug, right? The Ajug namespace, and it's actually the user container. Run queries. Let's make this for the last 5 minutes so it moves along here. So this is that 27 megabytes. That's your Node.js application. This 10 megabytes, that's your Java application. And the numbers vary because I literally just did this on the fly. But at this point, we've been working pretty hard. It used to be they were neck and neck on the memory footprint. Now we're a third of Node.js. We're a tenth of Java. Right? Let's see here, kubectl. With the Growl, this is with the Growl VM, obviously, right? Apply-f. I'll just run another app here. Can service. Okay, get that one going. Let's get the poller updated so that it actually goes to the right place. Oh, did I know? Oh, I don't even have the namespace here. It'll take a little while to come up. But if we come back here, right, this one will clock in around 100 meg or so. And I've tried to constrain it a little bit further. But it takes a while to come up. Come on now. Right? 0 of 2, you got to see it go 1 of 2, 2 of 2. By the way, that 2, by the way, says there's 2 containers aboard that pod. That's what it means. This is a feature of Knative or Istio. Typically, a pod is 1 to 1. 1 container, 1 pod. But you have sidecar containers with all this magical stuff. With Istio, you got all the blue-green, canary, the traffic routing. With Knative, you got the dynamic auto-scaling up and down. So you get the sidecar as an add-on. That's why you see the 2 of 2 there. All right, so let's see here. Okay, can poller. Will this work for me? All right, there it is. So it's going. And come on, Prometheus, we'll catch up. Here we go. So this one's about, we can't quite see it yet, but it's about a 90 meg, 100 meg. We'll see it scroll over there. So that's the part that matters, not your disk footprint, unless you have weird image issues and you have this crazy thing. I've been burned on disk footprint, but you will get burned on memory footprint. And the memory footprint is what you're paying Amazon for anyway, right? That's your bill. So that's, again, kind of our focus. With Quarkus and Growl VM, you can get ever smaller. With regular JVM, you're already smaller. With Growl VM, you're even smaller still, okay? Smaller and faster still. So, but I want to show you a couple other things. So this is all fun, and my little to-do application is cool. But one of the things we just added, because we showed you that syntax earlier, where this one. And how many people said they know JAX-RS syntax? This looks okay to them? Okay, not quite all of you, or not even maybe a third of you. So we actually respect that. We recognize a lot of people don't know that funky syntax, so we added this syntax for other people. All right, so here we go. This one might be more familiar to you. Right, so a lot of people don't know the traditional standardized Java way to do things. That's known as Java EE and microprofile and JAX-RS. You use this syntax instead. So this works now too. It's something we just did recently. You'll be hearing more about it in a couple weeks. Okay. So basically, you can use your traditional Spring annotations as well, and this thing compiles down to native executable. Just everything's the same, nothing different. This one, I might already have this one compiled. Let's see. Let's see here. Target. Yeah. So there it is. ls-lh target. Spring annotations on top of, but it also is, but I mean, if you look at the import statements too, right? You don't know it's not Spring, right? We just made magic happen, but it's 62 meg, target, Spring to-do app. Let's see if I can get this guy running. And so there's my Spring app in 0.39 seconds.
So you have a Quarkus speed?
What's it?
You have a Quarkus speed, like a Quarkus Hibernate, etc.
Oh, this is all with Hibernate, Quarkus Hibernate underneath there and everything else, right? All the optimizations apply. Okay? So, so we have other syntaxes we've been working on too, right? So we have the traditional Java E microprofile stuff. We have Spring. We also have Camel, right? So if you're familiar with the Camel program, anyone here familiar with Camel? Yeah, we got the Camel programming model working on. Vertex programming model, if anyone's familiar with Vertex, you've seen me do Vertex presentations, working on that syntax too. Not all, that one's coming a little bit slower, but we know who those people are, so that's going to be pretty neat. But again, the purpose of this is not for migrating any of your existing code, just keep that in mind, because we focus only on the use cases that matter to microservices and the serverless architecture I've been showing you. Your legacy code, where you have your old school EJBs and whatever in there, that works great in your existing Tomcat, your existing JBoss, your existing WebSphere WebLogic. It won't work here, okay? This is a subset of the ecosystem at this time. And it'll continue to be a subset. It's not meant for migration. It's meant for, I'm building a brand new microservice, because the people we built this for were rewriting everything in Node.js and Go, okay? But they were Java people, so we built it for them. Yes?
So is Spring working with you on this?
No.
So if Spring puts a new release out tomorrow, we gotta wait for you guys to. Okay.
Yep.
What kind of lead time you expecting?
Unknown at this point. Right now, it's just something we did just to see what it would mean to the ecosystem. This thing is all brand new. If you notice, it was just born in March. If you guys were here at DevNexus, we actually gave birth to it at DevNexus this year. So March of this year, and you kind of see it's still a 0.24. We're still in experimentation mode. There are people who have already moved it to production because they were so happy with it. It's an open source project. You can do what you will, obviously. But right now, we're still in experimentation mode. You're going to see us come out a little bit more aggressively, if you will, for this in the next 4 weeks, approximately. What? Let me get to this lady's question real quick.
Burr doesn't support Java 11 yet.
Java 11? Yeah, Java 11 just came on here, right? Let me see. I haven't even tried Java 11 yet, let's put it that way. But Java 11 is now, we've been working on it. That has been an issue. It's always been Java 8 syntax. And where is it? Somewhere in here. You'll see that we've started to add Java 11. Yeah, but by default, if you go with GraalVM, right? If you go with the native, that was Java 8 only. But they've been adding Java 11 and native. And I want to say I saw it in here just today. Where is it?
Quarkus is working with Java 11, but GraalVM doesn't support Java 11.
Yeah, but it's really close. It's really close. That is a limitation, though. If you need Java 11 syntax, you really are better off being on the JVM and not on the native image. But I was just looking at it today, and I just noticed it actually has a little Java 11 icon in here someplace, but I can't find it right now. Back there, Vince?
This is great, by the way. So, I missed the beginning, but are you running these things locally or in a cloud somewhere?
So the crazy thing you saw me running over here with all these pods running, right? That's in the cloud. That is actually running. That's running in the cloud. Where is it? That's running here. Okay. That's running on these virtual machines at Amazon. I could also pick it up, run on Azure, Google, etc. Right. The nice thing is we built it fully portable across all clouds. That's one. But right now I'm not running it that way. This was running locally. Okay. This is local, a local cloud. This is that big cloud I'm running. This to-do application that you saw me do earlier, that's local on the Mac.
Yeah, but I asked because one of the frustrations nowadays is that it's really hard to run cluster applications
Yes.
in the box. So this kind of helps towards getting some things back local.
Okay, it's a very good question. So, no, I actually appreciate your point because I have a guy who works for me at Red Hat, and he actually has a specific issue. I'm trying to upgrade his laptop. He's got a crappy old laptop, really, at this point. And so, therefore, one of the things we realized, he was really having trouble running traditional Java-based microservices on his laptop, especially when you have like a Minikube. So this is actually using something called Minikube here that I'm using. Okay, -p, -profile. I think this is my Knative one. Status, right? Yeah, or maybe IP. Yeah, this is the one. So this is Minikube. And in this case, I am running, let's check it out, Pukit pods, all namespaces. What am I running on this Minikube right now? Helps if you spell cube control correctly. Yes. All right, so look at all the stuff I'm running on that Minikube. So that was another thing. We found what he's able now with Quarkus compiled native apps, he can run all tons of stuff on his crappy old laptop. And honestly, as a manager, I'm getting him a better laptop. All right, so I'm working on that. It's coming. It's actually ordered. I got it through the budgeting system. But you know, that was something that we have noticed. If you, with the smaller based Java apps now, you can actually run a ton of microservices or do some of these scaling things that you saw me doing, like kubectl. Oh, unfortunately, I got this guy running over here. kubectl get kservices, right? This is my Kubernetes server, Knative services. There's my Quarkus, there's my Node, there's my Spring Boot. Again, I have Python, things like that. That scale testing thing you've been seeing me do, it's kind of hard to show right now because it's already scaled up. But the thing that I've been doing over here, I also do it locally. It's just that you can't go to 70 concurrent app servers on your local machine. Close, though. I've gotten up to 50 on my laptop. 50 app servers running. But there was another question over here, though. Make sure I go around. Yes?
So, sorry, I was here a little bit late, so maybe I didn't get everything. So my understanding is this is not meant to, all the Java application is only meant for like a newer, like a microservices, Lambda, small set of like a new Java application development.
Right.
And in order to benefit that, you have to use these Quarkus, like your Maven plugin, and also you have to import all these Quarkus version of library jar for like a REST, for like a database, any kind of library jar, you have to use the Quarkus version of the library jar.
Yes. Yeah, you don't have to use the Maven plugin. You could also use Gradle, right? The Maven plugin is just because I use Maven. That's just a convenience. But when it comes to these libraries, they've been optimized for this experience, right? They've been optimized for small and fast. So you got to use the libraries we've optimized. Now, you can use any library you want. You just don't get small and fast. All right, so people do that too, right? We have people who have all kinds of libraries that, you know, are traditional Java libraries. They still work in JVM mode. They won't compile to native, but they work in JVM mode. They're still smaller and faster for the things that we have optimized, even if that other library is still fat and slow. So your app may go from 20-second startup down to 10. You know, a lot of people are living in a startup world of what? Greater than 60 seconds still for your average application. Java applications are minutes-based startups typically, right? Not tens of seconds to tens of minutes. You know, so if we shave half that time off, it's still a win. Right?
So depending on how many library jar is already being optimized for Quarkus, so your kind of like optimization result could vary. And second thing is after you're using all these optimized like library jar or whatever, do you have to change any kind of like code for orientation or something? You don't have to, or you have to?
What you don't. I mean, if you look at the syntax I showed you, this is the stuff you're used to using. So we are looking for people to find the edge cases at this point. You know what I mean? So you tell us what you normally type that doesn't work. And we try to cover most of the cases. Now, I'm sure we've missed many, but you know, at this point we're looking at the community at large to basically tell us what other thing you want to do that we don't do. For instance, oddly enough, someone came to me and said they really had to have soap. We don't do soap out of the box. This happened to me a week and a half ago. They're like, we got to have soap. I'm like, yeah, soap's not quite ready yet, but it's close. You know? Yes, sir?
So the Graal VM managed by Oracle, What do you think future of that is as far as licensing?
Yeah, so that's a very good question. So what he's basically asking is for GraalVM. Let me try to bring it back up here again. If you notice, this is a project managed by the Oracle company, okay? And some of us in the Java ecosystem are a little bit unsure of Oracle, aren't we? Yeah. So the good news is, in this particular case, not only is Team Red Hat, Team IBM, and Team Pivotal, right? Pivotal is also working with the Oracle people to make this a good open source project. Yeah, so they just, at Spring One last week, they made the announcements for the Pivotal team as to what the work they had already been working on as well, with Oracle and the same thing. So all of us are contributing to GraalVM. Like, you know, there's real Red Hatters contributing all the time to GraalVM. And we're trying to get the governance model changed a little bit to make it more of a proper open source project, if you know what I mean. Yes, sir.
Since it's so new, I guess there's no great tutorial on this online to go through it, like a YouTube video or something to follow. Is there anything that, you know, you could go do, like a demo that's online?
The thing I just showed as an example, the To-Do app, I actually have a recorded version out here from, this was Minsk, a Minsk version, and I have one I did in Philadelphia. So you might check that out. There are actually very good guides. If you go to Quarkus.io and go to the guides section and getting started section, we have worked really hard to build a lot of great documentation. All right, so we got to do more. As a matter of fact, got a couple of guys on the team. We're working on an O'Reilly book. You know, we got a bunch of stuff coming. So you'll be seeing more and more roll out over time. Okay. What's that? Oh, what animal? What animal? I don't know. We just got permission to do the book. I just got the email yesterday, you know, and so I don't know. We haven't gotten to that point yet. We don't even have a title yet, I think. We just got permission to do the book. Yes. I want to show you a couple other things though, because if you guys have a few more moments, and here's why. Okay, this is a bit crazy. This is one of my demos I've been working on that I know is crazy looking, but give me a second here. This is, again, instead of being a CRUD-based application against a database, I want to be a Kafka-based application, an event-driven application, event-driven microservices. And so one of the things we've done is this thing called reactive messaging. So it's a reactive programming model against Kafka or ActiveMQ or other AMQP type things. And you can basically say at incoming, at outgoing. And in this case, because I have the in and out, it's a simple mapping of the data, right? So I can bridge from one place to another. I can bridge from A topic to B topic as an example. That's what's happening here. And because I have this, let's see here. Yeah, let's see. Let me kind of get the rest of this running. I'm going to get the rest of this infrastructure running. There's actually a lot here. It's a bit messy. But you notice I'm using the Quarkus dev across all of it. And it's connecting. This is my Kafka broker running over here. But now I can do some interesting things. Let's see here. Do I still have the stream-based one? But let's see. If I produce a message. So if you notice, I'm producing a message, and it's flowing through my entire system. Okay? And what's more interesting about that, if I come over here and change this. So let's say I can still have the edit, save, refresh world, right? So if I don't want that logic anymore, I want to use something that does a transformation, let's say, right? Let's come over here, right? It actually transforms the data in this case, rips it apart. And again, you can see it's a reactive programming model we've been working on. And let's push in another message. Okay, and then we get the Aloha thing out. But how do we, let me see. You can't actually see it very well because I have it running in a different place. Let me pull that up. It is running on, dun, dun, dun. I have notes for all this. I open source all this stuff, right? So, you know, try to keep it up to date. Oh, come on. All right, I think it's this port. I have so many things running here. Yeah, there we go. Dun, dun, dun. Oh, that one. And then push new message in. All right, and then over here. There it is, that one. Okay, so the concept of edit, save, refresh, again, Kafka as the primary thing instead of a database, and this different programming model you see here. And like we have this input output, you simply set up your application properties. But this concept is simply having a simple annotation that says, I want to listen to a stream from Kafka or AMQ, and the code is completely portable. So this is an example where we've been innovating, like the panache concept, making Hibernate easy to use. Let's make the Kafka programming model easy to use as well, and more importantly, completely portable between Kafka and ActiveMQ. Okay, so you can switch between the brokers by simply changing the configuration. That's what this little demo does. And there's a bunch of other work we've been doing in that space. We have been looking at all these different types of programming models, if you will, inventing new ones, using existing ones like Camel and Spring and things like that, and Vertex, but really trying to innovate in this space to see if we can make things more productive for developers. So that is really the focus here. Just like that edit, save, refresh thing, feels like a Node.js programming world. It's all about additional productivity. And I know we're out of time officially, right? Or officially out of time?
Yeah, but give you about 5 more minutes.
Okay. Well, let me just give you guys these things. So you want to get access to this slide deck here. The bit.ly Quarkus Java gives you the slide deck that I showed you early on. So make sure you make note of that one, right? So this link here, I guess it's kind of behind my head, isn't it? Wrong way. Wrong. Right? So bit.ly Quarkus Java will give you access to the slide deck. Quarkus.io will get you access to the actual website where all the magic is anyway. The Kubernetes stuff that I teach, as I mentioned earlier, also has some of those demos you saw me do earlier, right? The dynamic scale out on Kafka with the Knative and all that crazy stuff. A lot of those things are stuff that I teach on a regular, right here. So in this slide deck here is all my Knative stuff as an example. So that's the bit.ly serverless cube, right? And the Knative tutorial. So if you want to learn more about Knative, my team works on this Knative tutorial. Definitely check that one out. Also, if you want to learn more about Istio, check out this one. So that's the bit.ly Istio intro is this slide deck, and this is the class I teach on Istio. And then we have the book, the Istio tutorial, that'll basically show you how to do all the Istioized things. But these are advanced Kubernetes things, so just bear that in mind. The intro to Kubernetes is this one over here, this session, this slide deck. And you can kind of check out my links here. So bit.ly 9 Steps Awesome, GitHub Burr Sutter 9 Steps Awesome, which give you access to the little mini book that I've been writing there for intro to Kubernetes stuff. So intro and advanced, and then again, we looked at this Kubernetes. We looked at all this Kubernetes stuff, all this production grade clusters we've been putting in for customers. And again, the feedback was, can you make Java fast? So that's what we've been focused on. So the good news is with the OpenJDK team, with the JBoss team, the Hibernate team, people like that, we were able to figure these things out. That is all, but I do want to make sure we bring things to a close. I'll be available for a little while afterwards, but I want to make sure we wrap up on time for people who need to go and get back to their babysitter. I want to thank you all, though, for hanging out with me tonight. Hopefully you enjoyed the session. I appreciate that on a rainy night, a lot of you showed up, right? That's a big win, because that, it's when it rains in Georgia, in Atlanta, people just go home and cry, right? When they see snowflakes, they drive into the nearest ditch. But at least when they rain, they just go home. So I thank you guys for coming out. And again, I'll be around for a while to answer more questions or to just say hi to you, because it does feel like coming home for me, coming back to Atlanta. Thank you so much.
Hey, folks,